Hello everyone, my name is Matthew Dupree and I will be demonstrating how multi-threading works. So the best example I could come up with was using two countdown functions, or two timer functions. One's a countdown and one's a count up. They're both going to be one's going to be counting down from 10 and one's going to be counting up to 10. And I want both of these functions to run at the same time on the same thread. Now you would think that if I just called them in this function here, that they would just count at the same time. But instead, it's gonna count down. It's gonna do the first function first, count down, and then once countdown is done, it's gonna say that it's done, and then it's gonna start counting back up to 10. We don't want that. We want both of these to run at the same time. So, in order to do that, in order to access the threads, you have to use the namespace system.threading, and first you need to create an instance of the thread. So I have here two threads, thread 1 and thread 2, and I created them and instantiated them with the function count down and count up inside of them. So now when I call thread 1 start and thread 2 start, they will both start counting down and counting up at the same time. So you have timer 1 and timer 2, they're both counting down and one's counting up, and they're going to finish at the same time. And that's it. And the time you would want to use this is essentially when you really need two functions to be running at the same time, two things to be running at the same time. It's not really running at the same time. They're not running at parallel, but this is the best we're gonna be able to get into. This is the best explanation I could come up with for demonstrating multi-threading. Next, we're going to be talking about delegates. When I said delegates, I actually meant coroutines. So here I have a coroutine called invulnerability. In order to let Unity know that you're using a coroutine, you need to have this keyword here, or this keyword here, I enumerator. That's gonna let Unity know that you're about to start a coroutine. So for this coroutine, I'm making it so that the player is invulnerable after taking damage. So and it's gonna be inside of the update health function that I have. So whenever the player takes damage, it's gonna start coroutine invulnerability, and it's gonna run through each of these steps. So first, it's gonna set invulnerable to true, meaning it's a bool I have called invulnerable. That's gonna check to see if the player is invulnerable. After that, it's going to allow the player to ignore collisions on layers 8 and 9. It's gonna set that bool to true, meaning it will ignore those layers. After that, it's going to run through this for loop, and I have a number of flashes. This is going to be how many times the player flashes red, and it's going to take the sprite render color. It's going to change it to red with half opacity, or 50% opacity. It's going to wait for, it's going to do some math to determine how many times it can flash within this amount of time. And it's just going to alternate between red and white, red and white, red and white, this number of times. And then once this for loop is complete, it's going to re-disable ignoring. It's going to make the player unable to ignore layers 8 and 9, meaning it can be hurt again. It's going to reset invulnerability to false, so the player can take damage again. And to demonstrate that, I can. 1 second. Alright, so I have an enemy in this scene here. And this red box is the collider, so where it's going to actually start taking damage. So I'm going to start it. Alright, so the player takes damage. Now I've lost health, but if I stay inside of this and I'm still flashing, it doesn't attack fast enough. Hold on. I have to change its cooldown. Hold on. Okay. So as you can see, while the player is flashing red, he's not going to be taking damage. But once he is back to a solid color, he can't take damage, and he died. Okay. And here I'm going to talk about using delegates. So here I have a delegate that will store how the player will attack when eventually I'm going to implement being able to upgrade weapons and switch to different types of weapons that the player can use. There's going to be a fireball and a sword that the player can use to attack enemies. So here I store the private action, which is also a delegate. It's basically a generic template for a delegate. So here I'm naming it as attacking, and it's gonna start off as attacking. The player is initially gonna be able to use fireballs. He's gonna be able to attack with fireballs, and what that basically means is whenever the attacking function is called before a certain condition is met, it'll call the attack with fireball method, which is I have a function here. It's gonna start the attack with fireball animation. It's gonna reset the cooldown for how often the player can attack with the fireballs, and it's gonna instantiate the fireballs in the direction that the player is facing and wherever the fire point is. So what a delegate does is it basically stores functions inside of it. It can store functions, it can store classes, it can store all types of, or a bunch of things. It can help with AI states or state machines, but for here, it's basically a state machine. For here, I'm just using it to determine how the player attacks. So, as soon as the game starts, the player is going to be able to use fireballs, and whenever the player clicks the mouse button, a fireball will be shot. But when I also have the way I decide for just this demo, I have it to where whenever I press the M or the N, if I press the M key, it'll set sword, which is basically just swapping that delegate or swapping what's inside of that delegate attacking with a different function, and this different function will be attack with sword. I don't have any other code attached to attacking with sword yet. I haven't gotten that far, but right now it's just gonna start the attack animation. So to demonstrate this, so basically delegates really help with keeping code pretty simple, so you don't have giant state machines or a bunch of stuff in your update function. The only thing I have here is just the button the player presses when the player presses a button, what happens. So demonstrate it work in action here. So I have the player. Let's start the scene. Jump over this fire trap. So right now the player is shooting fireballs. If I press the M key, you see he pulls out a sword, and now he can attack with his sword. Now you may not want to be able to. This is good for assigning hotkeys, so switching out what's in your inventory. So I have it. If I press N, sword goes away. You can shoot fireballs again. And M. And that's pretty decent, pretty cool example of how delegates can work. I only have it as for my attacking situation, but it can work for all types of things. And it's really to help declutter code and make it easier to read, and to where you're not constantly writing attack with fireball. You're just swapping what the delegate is currently assigned to, and you call that delegate one time. And that's the end of my presentation. Thank you for watching.